Assalamualaikum everyone. Today my team and I are going to present our signal and system project. So today's agenda is number 1 to introduce the team, number 2 the objective, number 3 equipment or software, number 4 task 1, number 5 task 2, number 6 task 3, number 7 task 4, and lastly number 8 is conclusion. We have 5 members in our team. First, Nurkairin Jamila. Second, Zaitul Khadijah. Next, Aisyah. Fourth, Raihan Indiani. And lastly, Nurul Nadia. There were 4 main objectives in this project. Objective number 1 is to operate technical device for audio recording and image capturing in obtaining high quality audio and image. Objective number 2 is to perform various signal processing techniques to audio signal and image, including convolution, Fourier series analysis, fast Fourier transform, and image filtering methods. Objective number 3 is to demonstrate creativity and technical skills in composing and synthesizing music through the manipulation of harmonics and sinusoidal signal. And lastly is to demonstrate proficiency in using MATLAB for analyzing and manipulating audio and image. These are the equipment and software that we use in our project. First, built-in microphone on mobile phone. Second, built-in camera on mobile phone. Third is laptop, and lastly the MATLAB software.
Assalamualaikum, my name is Raihan Iliani and I will presenting task 1. For this task, we recorded the voices of all team members as they read their names, and then use MATLAB to convolve the recorded signals with impulse response of our choice. During the process, we faced challenges like aligning the signal properly and adjusting their length to avoid distortion. In the demo session, we will play the original voice recording, the impulse response, and the convolution output. Additionally, we will display the waveform of all three signals for the comparison. So this is the coding for task 1. On line first, the code reads an audio file and select only one channel if it's the multiple channel. For line 2, it is setup parameter for the echo effect. Delay between echo, the number of echo and how much each echo deflects. For line 6 until 8, it's check if these parameters are valid. For line 11 until 13, the code creates an echo pattern where each echo fades more than the previous one. For line 16 until 19, this echo pattern is normalized to keep the volume balanced. Line 22, the echo effect is applied to the original audio by combining the echo pattern with the voice. For line 25, the process audio is normalized again to avoid loudness issue. Line 28, the code plays the original audio, the echo pattern, and the final echo processing sound. For line 31 until 40, it is show three paragraphs, one for the original audio, one for the echo patterns, and one for the process audio. And finally, line 43 until 60, you can hear the original sound, the echo effect alone, and the final audio with the echo is applied.
Assalamualaikum, saya Raihan.
Saya Aisyah. Saya Kairin. Nama saya Zaitul. Nama saya Nadia.
Assalamualaikum, saya Raihan.
Saya Aisyah. Saya Kairin. Nama saya Zaitul. Nama saya Nadia.
Assalamualaikum and hi, my name is Nurkairin Jamila and I will be presenting task 2. So in this task, we need to compose a simple song for 10 seconds by using harmonics of sinusoidal signal. And in the image shown, it is the output sine wave for all the generated harmonics. This is the coding for task 2 and this is the first part. So for the amplitude and sampling frequency, I just use the original value given. And then for the harmonics, I generated 6 harmonics. Each one of them, I set different frequencies. And then for the last 3 lines is for the song to be played. So for the next part is to display which harmonic is playing. So when we run the coding, it will play each harmonics one by one from the first one until the sixth harmonic, and then it will play the complete song. And then for the third part is just to show the display of sine wave of all the generated harmonics. And the example for when we run the code is on the next slide.
Assalamualaikum and hi. My name is Zaitul Khadija and I'm going to represent about task 3, which is fast Fourier transform. In this task, we need to apply the fast Fourier transform function from the MATLAB into our own image. So, fast Fourier transform basically breaks down a signal into its individual sine and cosine wave. This allows engineer to see the signal frequency components instead of the sum of those components. So this is the coding that I use in the MATLAB by referring to the coding given in link for task 3. So the imread function is to read the image from your laptop. Next, the RGB to gray is to convert the original image to the gray image. Next, we apply the 2D FFT to transform the image into the frequency domain. The FFT function computes the 2D Fourier transform and the FFT shift to shift the zero frequency component to the center. Next, we apply the log transform. It's common to use a log scale when displaying the magnitude spectrum because the value can vary over a large range. And lastly, we reconstruct back the image by using an inverse FFT function. The result is an approximation of the original image. So this is the result that we got from the coding that we used. So the first one is the original image and beside it is the gray image. This is the result for the FFT function that we apply to transform an image to a frequency domain, and then shift function to center back the image. Next is the result of the log transform, and lastly the result of the reconstruct image using an inverse FFT.
Assalamualaikum, my name is Aisha. So the last part for this task is convolution of two-dimensional signal. So image and signal processing rely heavily on 2D convolution. It's combine two signal or function to create a third signal. Filtering, edge detection, and blurring are all frequent image processing tasks that require this procedure. So the example of kernel for the left side is Gaussian kernel, and the picture on this slide on the right side is Laplacian of Gaussian log kernel. Next, the coding for task 4. For the first line, I upload the original image from laptop. Then the next line is for iBlur 1, we use smooth image for Sigma 2. Next is Sigma 4, and smooth image for sigma 8. And then for the iBlur X1, we use to use for different standard deviation along row and column dimension for smooth image. Sigma x is 4 and sigma y is 1. Next for x2, smooth image, sigma x 8, sigma y 1. For y1, smooth image, sigma x 1, sigma y 4. And for y2, smooth image, sigma x is 1 and sigma y is 8. So for the eye wall, I'm I made just I 2.50 and 10.70 for the showing sky in a wall in original image. Then for what iBlur X1 for sky in filter image. This is the result. For smaller standard deviation sigma 2, this leads to a narrow and more concentrated Gaussian distribution as a result. The output figure, sigma 2. The image will retain more high frequency information and undergo less smoothing. They maintains delicate structure and edge for moderate standard deviation for sigma 4, maintaining detail while striking a balance between them. As a result, four, the output figure sigma 4 strike a balance between noise reduction and edge retention by offering a moderate amount of blurring. Next, for large standard deviation sigma 8, the Gaussian distribution become large and as a result, it produces a greater degree of blurring and smoothness. Lessen the presence of high frequency detail while improving the image overall harmony. A more consistent blurring of the image may result from the less obvious edge. Next on task 4, edge of our original image using Laplacian of Gaussian log kernel. For this part, the first line I'm read for original image from laptop. Next is grayscale image for RGB2 gray image. So I'm show gray 2 scale image for original grayscale image and blur sigma for array 1, 2, 3, 4. And then first for sigma IDX and current sigma and blur image. Then the next part is log sigma for part 1, 2, 3, 4 for log IDX, current sigma, log kernel and edge detected. This is the result for task 4 part 2. The first left is Gaussian blur with sigma 1. Next is Gaussian blur with sigma 2. And at the right is Gaussian blur with sigma 3. Then the last one is Gaussian blur with sigma 4. So from this picture, I got the when the large of number, more the blurring the grayscale image. The last one for result for part 2. Firstly, edge detection with log sigma 1. And next is edge detection with log sigma 2. Next is edge detection with log sigma 3. And lastly is edge detection with log sigma 4. So the output is then displayed on the filter has been
applied to the original image using IM filter. Every graphic depicts the application of a particular log filter with corresponding setting. Okay, so just this is just so I am done for the task 4. Thank you.
In conclusion, this project successfully demonstrated the application of signal processing techniques across various tasks, including convolution, Fourier series analysis, fast Fourier transform, and image processing. By utilizing MATLAB and basic recording equipment, the team explored the practical implications of these methods in audio and image analysis, showcasing their relevance in fields like engineering, telecommunications, and multimedia. Through this collaborative effort, the team not only achieved the stated objectives but also gained valuable technical skills and insight into signal manipulation and creative synthesis.